All right, next. Write an equation for the nth term of the geometric sequence. So again, we want the same instruction. So I ask myself, do I have a sub 1? Do I have r? If I don't, then I have to go find those things. I do have r. It's pretty clearly written here. R is 6. I don't have a sub 1. So the way that I'm going to solve this is I'm going to use this formula to my advantage because I know it's geometric, so I can use this. Here's what I have. I have r, and I have a term in the sequence. I have the fourth term. Okay? In other words, when n is 4, I know that a sub 4 is 5. Okay? In other words, I'm going to write this. A sub 4 is equal to a sub 1, which I don't know. I got to figure that out. R, though, is 6. And if I'm using the fourth term, then I know that n is 4. So 4 minus 1. Okay? Not only that, I know what a sub 4 is. It's 5. So I can write this. 5 is equal to a sub 1 times 6 cubed. 6 cubed, I have forgotten what that was. So 6 raised to the third power, 216. Okay, so this is going to be times 216. And so now if you want a sub 1, you just take 5 divided by 216. So let's do that real quick. I don't think it's going to be a nice number. 5 divided by 216. No, it's not. Is it a nice fraction? No. Yeah, 5 over 216. All right, so we'll just leave it like that so we don't have to write down that nasty decimal. A sub 1 is 5 over 216. Okay, so now I can write my rule. It is just this. A sub n is equal to 5 over 216 times 6 to the n minus 1. Right? Probably fractions are going to be better than decimals here anyway. Okay? So let's move on to the next example. Find the 3 geometric means between 2 and 1250. Okay, so what we've got here then is we have the first term and we have the fifth term. Let me make that explicit here. We have 2, we don't know, we don't know, we don't know. We've got 3 missing terms. And then at the end here we have 1250. All right, so here's a sub 1. Here is a sub 5. And you can see that this is a very similar problem that we had over here. No, I'm sorry. My mistake. It's not that similar. I had it confused in my mind. Okay, so I have the fifth term. I have the first term. I need r. Okay, and so here's how I'm going to go get r. I'm going to, again, use this formula to my advantage. So I know the a sub 1, so I'll plug that in for a sub 1. I don't know r, so I'll leave that as r. But I know that the fifth term is 1250, so I'm going to write this. 1250 is equal to 2 times r raised to the 5 minus 1, because I'm taking the fifth term, n is 5. All right. Now I'm going to solve this. I'm going to divide by 2, so I will get 625 over here is equal to r to the fourth. And then I'm going to have to take the fourth root of both sides. Fourth root of both sides. So I'm going to go over to Desmos. I'm going to use the fourth root command, so I'll bring up the keyboard, bring up functions, bring up miscellaneous, nth root. I want 4 and 625, and you can see that my answer is 5 on that one. Okay. So I get that r is 5. Now I'm not done yet because I'm trying to find these missing terms, but now that I know the common ratio, I can get them. So 2 times 5 is 10, and then I'll multiply this by 5, so that'll be 50. And I'll multiply this by 5, that'd be 250. And so there are my 3 missing geometric means. Okay. So we are going to need to use this formula here in a lot of different ways. Last thing we're going to talk about, geometric series. Okay. Geometric series is the sum of a sequence, a geometric sequence. All right, so for a series, we just take a certain number of terms in a sequence and we add them up. So if we wanted, we could turn this into a series question if I said, what is the sum of the first 4 terms in this sequence? And you would just take and add these 4 numbers together. So when you see the word series, you're going to think sum. All right. Now, for series and summations, when we're taking sums, we use this what's called summation notation, which is an uppercase sigma. Okay, and this uppercase sigma is denotes or tells us that we're going to take the sum. In this case, this is our rule that we're following. Okay, or our equation. Okay, so that's our equation. And then it tells us we want the third term to the 10th term. Now, I think all the problems in the assignment start just at the first term through the 10th term, or sorry, just at the first term through some other term. So I'm even going to start that at 1, okay? And so what this would mean is we would take the first term, which is going to be 4, plus the second term, which would be 4 times 2 to the 1, plus the third term, which would be 4 times 2 to the 2, plus dot, 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 all the way to the end, which would be 4 times 2 to the 10 minus 1, so the 9, right? And you want to add all of those up. Now, the good thing for you is that the calculator will do this for you. If you want me to show you on the TI-83, I can show you in class. I'm going to, again, show you with Desmos because it's so nice. But let me show you how we would do it in Desmos. In Desmos, let's get rid of all this other stuff. All you have to do is type in sum, and it will bring up that notation. Excuse me. So what we want is sum from 1 to 10. So that's the first 10 terms of this sequence. And so we're going to go 4 times 2. Now, your book is going to use K a lot of times, but Desmos defaults to N, so we'll just use N. So N minus 1. And there it goes. It tells us what the sum is right there. So if you add up the first 10 terms there, in that sequence, you will get 4,092. Okay, so 4,092. All right. So the last problem here, we're going to actually try to do one of these problems on our own. You might pause it here and see if you can figure it out. What we want is the sum of the geometric series given the following. We have a sub 1, we have the common ratio r, and then this tells us that we want the first 8 terms. Okay, so let's write out the summation. So this is, we'll write the sigma here, and then we're going to start it at k equals 1. We're going to go up to 8. Okay, and then our rule is geometric sequence, so it's going to be 36 times r, which is 1/3, raised to the n minus 1. And that's exactly what we're going to, or k, sorry, k. That's exactly what we're going to put into Desmos. So once you do one of these, you'll have the format already in Desmos, and you'll just need to change the numbers around. So let's go change that to 8. We want 36. We want 1/3. To the n minus 1. And you can see it doesn't come out to be a very nice number, although I think it is a fraction. Yeah, well, we'll just go with the decimal. So it ends up being 53.99 for the sum. Okay. And that's it for geometric sequences and series. You're going to want to probably come back to this video maybe 1 or 2 other times just to kind of double check your understanding of the vocab if you get confused by the notation or anything. But it's really just using that one formula a lot and then just knowing the notation in the other places. So that's it for section 3.